Hello everyone. This week we're going to talk about network protection systems, and if you hear Baby Shark in the background, I am sorry because I don't want to hear it either. So again, this week, network protection systems, we're going to talk about how routers are used as NPSs. We're going to talk about firewall technology, the various tools for configuring your firewalls. We're going to talk about IDSs and IPSs, so intrusion detection and prevention systems, and web filtering technologies. So we talk about items on the application layer, and we're going to talk about honeypots. So what are NPSs? It's a device, so again, network protection system, NPS, and I'm sorry if I throw some acronyms around. It's any device or system that's designed to protect a network. So unified threat management devices. It's a single device that combines NPS functions. So if you have routers or firewalls or IDS or IPSs that perform security functions, VPNs, web filtering, it's all of these devices. And a security appliance covers both UTMS and NPSs. So routers are hardware devices. It's used to send packets to various network segments, direct traffic, and these operate at the network layer in OSI. There's various routing protocols, link state, where the router advertises its link state, distance vector routing protocol, where a router will pass its table to all participating routers, and path vector, where the paths are chosen and the routing tables are chosen dynamically. Cisco routers are widely used. More and more companies are entering the space, though, and they're a high value target because if you can find one vulnerability or find one 0-day, obviously you have a lot of potential targets. Vendors are offering competitive products. So you're going to see various routing products from competitors, and vulnerabilities exist in all of them. However, Cisco is the most ubiquitous, and therefore they're going to be attacked more often. It's much like in the early day, well, not so much anymore, but when Macs weren't as prevalent, iOS devices weren't around, Windows machines were the target virtually all the time in terms of desktops. And you get the same kind of behavior in the networking community. In a router, in a Cisco router specifically, you have RAM. Obviously, it's dynamic, holds the current running configuration in iOS. And when I say iOS going forward, it's Cisco iOS, which is the operating system that is run on Cisco router components. Holds the routing tables and the buffers, and obviously it's volatile. Like I said, dynamic. So if the power is removed or turned off from the device, the contents in the RAM are erased, just like on a normal PC. And VRAM, non-volatile RAM, the name, it's persistent. So it remains static even if the power is removed. This is where you're going to hold your configuration data, and your flash memory is rewritable, but it's slower, obviously, than accessing RAM. So it's persistent and it's rewritable, but you can think of it akin to a disk. Read-only memory, ROM. This comes from the manufacturer. It contains the base OS, the base version of iOS. And your interfaces, these are your hardware connectivity points. These give you access to the LAN. There's two modes that we're going to talk about. User mode, basic troubleshooting tasks and tests. You can list information. This is the default mode. And then privileged mode is where you can perform router configuration. Global configuration mode, there's two modes within privileged mode. Where you can configure the global settings affecting router operation. And in the interface configuration mode, the administrator can configure any interface on that router. And here's an example of some Cisco commands. So when we look at access control lists, or ACLs, there's lots of types of ACLs. This part of the book focuses on IP access lists. So basically, it lists IP addresses, subnets, or networks that are either allowed or denied through ACLs or DACLs and a router's interface. And a Cisco router access list, there's a standard IP access list and an extended IP access list. So with standard IP access lists, this can restrict IP traffic that's entering or leaving a router's interface based on the source. So for instance, if we wanted to restrict traffic in the diagram from network 3 from entering network 1, you would have an access list where you define access lists and you deny the network 173.110.00 with basically any of the subnet configuration after that. And then the access list, the one lower than that in precedence, is permitting any. So this will block network 3. We look at extended IP access lists. This is going to restrict IP traffic entering or leaving, and it allows you to look at a little bit more: source, destination, protocol type, as well as the port. Configuration is very similar to the standard IP access list. When we look at firewalls, again, these are hardware devices with embedded operating systems. This controls access to traffic entering an internal network, as well as that traffic leaving the network. The advantages of a hardware firewall is obviously it's faster than a software firewall, but it can handle larger throughput. And the problem with the hardware firewall is you're locked into a specific vendor. Software firewalls, obviously you can change the vendor, but you rely on whatever operating system you're running, and more difficult to configure, it's a bit slower. We look at firewall technology. You have NAT access lists, packet filtering, stateful packet inspection, and application layer inspection. So we're going to talk about each of these. So in NAT, network address translation, this is the most basic security feature of a firewall. You have a set of internal private IP addresses mapped to a single or a few public external IP addresses. This essentially obscures your internal infrastructure, but don't think NAT is a solution to everything. And along with NAT, you have PAT, which is port address translation, and it allows specific ports to be mapped as well. Access lists allow you to filter traffic based on either source or destination IPs or ports. Firewalls also use this technology, and you can create access lists in a firewall similar to creating them in a router. Packet filtering allows you to basically look at the packets, and you can screen traffic based on the content of those packets or the headers for those packets. Content packet inspection is a little bit more difficult once you get into encrypted protocols and tunneling, but the headers are usually fair game. And again, you can screen the packets and create rules based on these filters. Stateful packet inspection. This is session-specific information along with a state table. So this essentially makes port scans that rely on spoofing or sending packets using a three-way handshake ineffective. Stateful packet filters monitor the state of the ingoing and outgoing packets, or incoming and outgoing packets, and they can recognize anomalies. Again, you can look at behavioral analysis over time, compare them to either behavioral signatures or use AI. In stateless packet filters, you're not tracking the state of multiple packets, but you're looking at each individual packets on its own, but that's not resistant to spoofing or denial of service. So here's an example of a stateful packet inspection using a state table. Application layer inspection allows you to look at network traffic at the application layer. So layer 7 in the OSI model, it allows you to look at network traffic, the application protocol that's being used, and specific types. And some application firewalls also act as proxies for connections. So if you don't implement a firewall, obviously it will leave your network open to attack. Obviously, you have to have some sort of rules engine to put this in place. But simply placing a firewall between a company's network and the internet is a bit dangerous. So when we talk about defense in depth, using a DMZ or a demilitarized zone is another layer of defense. Essentially, it's a small network that has resources that a company wants available to internet users, but it blocks out everything else in the network. It sits on its own little island, but it sits also between the internet and the internal network. So you can think of it as it sitting on the perimeter. So here's an example of where a DMZ would sit. And again, if you wanted essentially 2 levels of firewall, you could do that as well if you didn't want pure direct access to get to the DMZ from the internet. So the Cisco Adaptive Security Appliance, or the ASA firewall, it's very widely used. I've used it at a number of organizations. It replaced the PICs from Cisco, and it added a bunch of features, IDS and IPS, and application layer inspection as well. There's a similar login prompt as the Cisco router. Again, many of the commands you use will be very similar or the same. Obviously, you want to put a legal prompt, not that anyone will listen or care, but you can put it on there. And a question mark or help will give you a list of commands. When you enter a correct password, you're in privileged mode. If you want to enter configuration mode, here's the command. And access list, just like on the Cisco routers, again, used to filter traffic. And you can view an access list type through show run access-list. So you can use configuration and risk analysis tools for firewalls and routers. So CIS, or the Center for Internet Security, has a really good website for finding configuration benchmarks and assessment tools. What is a benchmark? It's an industry consensus of best configuration practices. So CIS puts out the Cisco IOS benchmark, which is a baseline you should consider when you're configuring your Cisco routers. CIS also puts out their CAT, or Configuration Assessment Tool, which is available for Unix and Windows systems that you can use to assess your configurations. Red Seal is another tool. It looks for configuration vulnerabilities in routers and firewalls. It builds a report out for you. It analyzes intrusion prevention systems and looks at OS vulnerability scans, and it gives you a nice little graphical representation of what it's found. Here's an example of Red Seal and its network risk map. So IDS and IPS, intrusion detection systems and intrusion prevention systems, these monitor network devices. As a security administrator, helps you identify attacks in progress and stop them. IDSs look at traffic and compares it with known exploits, almost like a signature when you're looking at virus software and DAT files. IPSs are similar to IDSs, but it doesn't look in the past. It tries to prevent the intrusion by watching activity. Network-based IDSs and IPSs monitor activity on network segments. They also sniff traffic, and they will alert you if something suspicious occurs. Whereas host-based IDSs and IPSs, they'll protect an individual or multiple servers, and it's a piece of software that's installed that performs the same function as it would on the network. There's two types of IDSs, active and passive. Passive IDSs, they just log. They just alert. They don't take any actions, whereas active systems will not only log an alert, but they can interoperate with routers and firewalls, shut things off, add rules. That's, again, what it means by active. And vendors have really started focusing more on IPSs. In the cyber community now, everything is AI, everything is machine learning, everything is behavioral analysis rather than signature-based analysis. So again, IPSs look to be more intelligent, very active, capable of stopping malformed or malicious traffic. Anomaly-based IDSs, they take a baseline of your normal activity, so you'll typically sit this thing out for a week or two. It'll get an example of how your network operates, and it will create a baseline. And then after that set of baseline analysis, anything out of the ordinary is stopped or quarantined, or you get an alert. So that's what an anomaly-based system is. It has a period of time of learning on installation. Web filtering, essentially it's a system. You can have host-based, network-based, you can have hardware, software-based web filtering. That just sits between an end user or all your devices and the internet and filters various websites, various traffic. Barracuda is a very popular one. That was one of their original products, was a web filtering engine and an email filtering engine. And it basically allows you to filter out bad traffic. It can also be used to detect users' browsing habits, block malicious sites, prevent users from performing certain activities, and also prevents drive-by downloads. What is a SOC? It's a security operations center. It's a team, oftentimes a physical location where the team is housed will be called the SOC as well. And these members are there solely for monitoring the organization's cybersecurity status. They watch for indicators of compromise. They look for artifacts. They scan the network. They read logs. They use SIEM tools, security information and event management tools, to identify past or ongoing or potentially future attacks, indicators of compromise, and they use these tools to collect, aggregate, and log data and correlate them. So what is a honeypot? It's not just a computer, but it's any attractive device, virtual machine, placed on, or even network path, placed on a network perimeter to lure and trap. And you have to be hackers, and you have to be really careful about this because the book says the word trap. That's illegal, folks. You can entice, but you cannot entrap. If you entrap one of these hackers to use a honeypot, you will not get very far in the legal system. You won't be able to arrest them. You won't be able to sue them. It's the same reason why cops can't just plant drugs on you. You cannot entrap people. You can entice. Someone has to make a decision out of their own free will to enter your network. They have to make the bad choice. You can't force it on them. But again, it's just putting a system out there that looks really attractive to entice a person to break in. And then you log all their data and you send it to the FBI and let them break down their door. A honeypot looks like it has important data on it. Again, it tries to attract people, entice people. And in virtual honeypots, as I mentioned, VMs, these can be configured without building out a physical machine. So this chapter, pretty short, we talked about NPSs, routers, firewalls, IDSs, IPSs, web filters. Talked about routers. We can use them to accept or deny traffic. Firewalls, they can be hardware devices or software installed on computer systems. They can use a NAT, packet filtering, ACLs, DACLs, stateful packet inspection, and application layer inspection. We talked about the Demilitarized Zone. Essentially, it's network resources you want to make available outside the organization, but you don't want to give those internet-based outsiders access to your network. We talked about intrusion detection systems and intrusion prevention systems, IDSs and IPSs, network-based, host-based, passive, and active. We talked about configuring routers and firewalls, web filtering, SOCs, as well as honeypots. Be careful with the honeypots, folks. And that's all for this week.